Strongly typed IDs are like any other strong types. If you don't send plain strings or ints or enums around your application, but you wrap them into domain models, then you should be doing the same thing to strongly typed IDs. I mean, you should wrap plain ID values into domain models for IDs. In this application, I will show you how you can use strongly typed IDs in a complex domain model and then integrate them into Entity Framework and into Razor pages, so the entire application will be strongly typed. This model class is using a primitive type ID right now. The problem with this primitive value is the same as with any other primitive value. You have heard of primitive obsession. Well, this is primitive obsession applied to IDs. I could mistakenly assign the wrong ID, the ID of some other entity, to this object, causing effectively an assignment bug. What I want is this instead: a specific type for an ID of the book model specifically. No plain value can be legally assigned, regardless of its source of the excuse I might have how I got that value. Now, this is a strategic decision. It will affect all the layers in the application, from the database to Entity Framework to domain model to UI. And more, all other classes in my application will be affected. Not just the models, but also the services, the helper methods and everything else that works around the domain models. This specification is helping me query the database, not by GUID anymore. I must pass a strongly typed book ID if I wanted to have a book. A book's price model is another domain model. It must also be more specific. It can only link to a proper book, not to any other object, no more. Creating a new book price requires a proper book's ID. I cannot create a book price given a GUID. What is that GUID? How did I get it? It must be a book ID object. The same will stand for authors, now with a strongly typed reference to the book. Strongly typed IDs are a native part of DDD. But the trick is that you don't have to apply the full DDD to use them. They're just useful for themselves. You can watch my other video where I have explained or listed all those elements from DDD which we are using in all projects today. They have become part of object-oriented programming. There's the link to that video in the description. By this point, I have turned all the domain models and services to use the strongly typed book ID. It would be easier if I did it on the outset, the first time I created the book model. Currently, I'm doing the refactoring, so it's not that easy. I didn't do the UI yet. The Razor pages. Razor pages are notoriously textual. The GET action will receive a GUID parsed from a plain string received from the internet, from the URL. That is, two primitive types at once, string and GUID. I will request a strongly typed book identity. This will not work out of the box, but you will see the fix will be straightforward. A GUID here is just an implementation detail. I want to talk in terms of the ID of the book. I don't even care what underlying type it is. But now it works in the opposite direction too. This partial view is rendering a link to the book details page. I'm dismissing the broken links with this change. The containing component, the component in the UI that contains this partial view, will now have to work in terms of strongly typed book IDs, or otherwise it would not compile. Before I show you the implementation, let's make a short break. I know many of you are learning also from video courses, so I have some coupons to share with you. DomeTrain is an online courses platform run by fellow content creator Nick Chapsas, and it is the go-to place for up-to-date courses on modern software engineering topics. From testing to clean architecture and modular monoliths all the way to DDD, microservices, Docker, and Kubernetes, DomeTrain has a rich collection of courses that will help you get up to speed with each topic by expert authors who have been practicing what they teach in real companies for years. DomeTrain just launched DomeTrain Pro, a subscription offering that gives access to all of the platform's courses. With more than 24,000 satisfied students, you can't go wrong with DomeTrain, and the first 100 of you can use code Zoran to get 15% off the price of any course. Alright, back to code, where I will show you a straightforward method of implementing strongly typed IDs for all domain models. We can support these two operations with a pair of static factory methods. Turn the ID typed into a read-only record struct. You can watch my other video where I have explained why I make strongly typed IDs this way, like read-only record structs. If you don't feel like learning advanced C# now, this is the shortcut to that learning. Read-only record struct is the method that works just fine. You can even use default here, evading all constructors. There's yet another of my videos explaining the funny angles of records, record structs, validation and everything. That video is also in the description and you can watch it as well. Guess what? I have implemented this strongly typed book ID. Entity Framework is next. Entity Framework Core is supporting strong types almost natively. Pick the ID property and tell Entity Framework there is a conversion to apply. When given the strong ID, poke the contained value out. The underlying database will contain these raw values, and then when you load that raw primitive value from the database, wrap it into the book ID instance for future use. The funny part is that this is all I need to do in the Entity Framework configuration. It will pick this conversion up and apply it to all foreign keys, and there are quite a few foreign keys referencing books in my database. So that will just work. I go up to the UI. My custom ID should behave the same way as the primitive value did. The toString decides how this URL is formed. So back in the book ID record struct, I add the toString override to forward the call to its contained primitive value. This completes the upstream scenario. From the database, the physical storage, through Entity Framework, through domain models, up to the Razor pages and UI, everything works fine at this moment. The downward flow remains where I must indicate a specific model binder whose job is to convert the incoming string into the book ID type. This class is mine. I added it to the project. Here it is. It is a custom implementation of the iModel binder interface. The bad news is that you have to do this. The good news is that you only need this one class in your ASP.NET Core project, and you have just supported all strongly typed IDs for all the entities in the model uniformly. That is all, as you can see, 40 lines of code. With this class in place, the GET action will indeed receive the book ID now when called from the internet. Isn't that wonderful? Sure it is. You can download this entire source code and read it for yourself. Join the growing community of patrons who are helping keep this channel free for everybody else, and get access to the source code of all the videos, more than 100 videos I have already published. You can also get access to the future video course which I am working on right now. You can take a sneak peek. All the links are in the description. I will now add an EF migration for the strongly typed book ID. This is what Entity Framework has made for me. Nothing. An empty migration. That is the most beautiful aspect of all this refactoring I did. It only affects my model, my application. The database will remain the same as it is. The internet will remain the same. Only my application, my domain model is affected, and affected to the better. I will remove this needless migration. Let me show you the application running now. This is the list of books queried from the database. You might not be able to see the small print here in the corner. It is the GUID from the strong ID serialized to string and used in the URL. Model binder, my custom model binder is also working fine as it appears. So it seems that my code written in the strongly typed C# language is now strongly typed itself. It includes strongly typed book ID in all the operations. Some hard questions still remain though. The first issue is visible here. It is the loss of safety when the value leaves the application to the internet. It's a plain GUID. I could supply this GUID to the wrong page, and that model binder will deserialize it into some other strong ID. So it looks like the assignment bugs are back in the game again. I want to fix this as well. So the solution. This is the final version of this demo. You can also find it on my Patreon page. I have added a helper class that can serialize strong IDs by prepending the type name or the part of the type name to the value. And then the deserializing method is checking whether this thumbprint is matching the target type before instantiating a strong ID. You know what? HTTP is a textual protocol. What I did was that I have stringified my strongly typed IDs to work with that textual protocol. But when getting out of the textual protocol back into the safety of the strongly typed ID, I have destringified those values back into strong types. Every strong ID type will now rely on this helper class for serialization and deserialization, making the entire web application strongly typed. I hope so. I have added some logic to the model binder to use try parse when available. This is a strongly typed ID for the person class where I store book authors. It shows one additional benefit of strong IDs. The database table containing person objects has a clustered index on the key column that is usual in SQL Server databases and many other databases too. Now, if you want to supply IDs from the application and wish to retain the clustered index in the table, you must use the key generating algorithm that will produce IDs in the ascending order, or your clustered index will become fragmented and its performance will be ruined very quickly. The story of clustered indexes doesn't end here. Sometimes you won't be able to use sortable GUIDs or UUIDs or anything that is sortable. When that happens, you would probably have to give up the clustered index. Now, whether it is affordable to give up the clustered index, that is a totally other topic. I have made another video showing how, if it happens that you must give up the clustered index, how you can do that using Entity Framework Core and SQL Server. So watch that video as well. There's a link in the description. But the major takeaway you should accept from this screen here is that the algorithm and the type are encapsulated in the strongly typed ID definition, and nobody else knows what decision that is. Keep that in mind. The last example I will show you is a wrapper around an autoincrement integer generated by the database. Another common case, you can use autoincrement IDs if there are no special requirements. Why not? Well, here I can wrap one into a strongly typed ID. Who's to stop me? There's a difference. There is no create new factory method here because this strong ID type is not creating the values the database is. Another nice detail is that the book has a nullable publisher. Entity framework, when I give it the value conversion, will maintain nullable publisher ID. It will just skip conversion when it encounters null. So again, all this will work out of the box with Entity Framework. Let me run the application one more time to show you the results. The URL to the book details now includes a prefix saying it is the book's ID it holds. Look, the link to the book's author will contain a different stamp, person. If I try to hack my application and submit a person's ID where the get action expects a book's ID, that attempt will fail. I have programmed the get action to gracefully fail by redirecting to all books page when the model binding of the book ID fails. So since I did end up in the all books page, it looks like my hack didn't pass. The model binder failed and the get action caught that failure and didn't attempt to assign the author's ID where the book's ID is expected. My application is safe on all ID assignments. So you have seen it all, from GUIDs to universal lexicographically sortable IDs, UUIDs, to ints, from application-generated values to database-generated values. From URLs to models, I have covered all the angles, and strongly typed IDs worked in every single one of them. If you have got rid of primitive obsession in everything else but IDs, now is the time for you to make that final step and get rid of primitive IDs obsession too. I hope you liked this demo and that you will apply these techniques in your projects from now on.